Greetings, Mr. Kolozar's class. Today we're going to look at section 4.4 and the idea of how ions differ and what ions actually are. So we're going to look at the atomic number and how we can use that to define the atom, but then we're going to be really focusing on the ion, using that atomic number and mass number, but most specifically the atomic number to help us out on calculating. Now, to begin with, defining the ion. The atomic number of an element is equal to the number of protons. So by definition, the atomic number is the number of protons. When an atom becomes charged, it is now called an ion, meaning it's either going to become positive or negative, depending on what happens. In your notes, just fix up the charge of an ion is determined by the number of protons and electrons. Just fix that up a little bit if it is wrong in your notes. When the charge is positive, it's because the atom has less electrons. When the charge is negative, it's because it has more electrons. We can only change the number of electrons. So the amount of charge is determined by the overall difference between those protons and electrons. We can't change this. Can't change the number of protons, but the number of electrons can change. So the overall, if we're neutral, the positives equal the negatives. If we're an ion, then there is either more plus or more minus. So they do not equal each other for an ion. And so to look at that, we're going to look at the charge of the ion, the number of protons, plus the number of electrons. And I like to call it backwards math. The idea of backwards math, electrons are negative. So if you have more electrons, you're going to have a negative charge. If you have less electrons, if you take electrons away, you're going to have a positive charge. And so that's kind of our idea of, backwards math. And since electrons are negative, more negatives gives you negative overall. Less negatives gives you a positive charge. So if we look at this chart down below, one word I'd like you to write in, superscript. So a superscript means written above, and that's going to be these charges that dedicate that this is going to be an ion. So a superscript written above tells us we're an ion. So sodium, element 11 on the periodic table, must have 11 protons. But now since we have a positive charge here, to get a positive, you must have more protons than electrons. And since there's no number, we assume that it's number 1 there, but we don't write the 1 in. So 10 electrons, 11 protons to give us that 1 positive charge. Oxygen, element 8. So it has 8 protons. Notice it has a -2. That -2 there means we must have 2 more electrons than protons, 10 electrons total. And aluminium here, +3. Aluminum's element 13 on the periodic table, so 13 protons. Since it's a +3, it must have 3 less electrons, so we have 10 electrons total to get us that charge of the ion. So the electrons are the only thing that can change. You can't change the number of protons here. Now ions do behave differently than their neutral atoms. So example, lead versus Pb+4. They are chemically different. They have different chemical properties once they have gained or lost electrons. And those electrons we're going to talk about next chapter are the valence electrons, or those outer electrons are more importantly the ones that are actually changed, so that changes the chemistry. Our last chart, a couple things that just got changed in here. This is the element 2 instead. And then from there, a couple other changes we have. Make sure that we include helium up there, lithium, and the carbon. Are all a little bit changed up from what we had to begin with. So if we look through these problems to begin with, if you have 8 protons, you must be oxygen. Atomic number is 8. Mass number 16, number of electrons 10. So if you have 10 electrons, mass number 16, 8, you have 8 neutrons. But if you have 10 electrons, we write O, it's going to have a -2 charge to it. So oxygen with a -2. Lithium has the little plus ion symbol next to it. So lithium atomic number 3, mass number of 7, number of protons for lithium, atomic number is 3. And if we notice the electron amount here got changed to 2, that shows us that we have that positive 3. And then 4 neutrons, 7 minus 3, atomic mass number minus the atomic number, gets you that 4 neutrons. Now helium has a -2 charge to it in this case. So helium with that -2, atomic number of 2, mass number is 4 for helium from the periodic table. Number of protons would be 2. If we're at a -2, we're going to have 4 electrons to get to that -2. And then mass number minus atomic number, 2 neutrons for helium. Carbon 12 with a -4 charge, atomic number for carbon is 6. Mass number for carbon 12 is 12. And then from there, number of protons, carbon has to be 6. Now to get that -4, we would need 10 total electrons. And our last step to get to carbon is going to be to get 6 neutrons, mass number minus atomic number. And then lucky nitrogen, just by itself, there's no charge, so nitrogen's neutral. Atomic number for nitrogen element 7. Mass number is 14. Since it's neutral, protons equal electrons, and then 14 minus 7 is 7. What I would like you to do now is to work on worksheet 4-2.